All right, let's talk crypto. But forget the hype, forget the price charts for a minute. Today, we're going under the hood to look at the technology itself. This idea of a new kind of financial infrastructure. We're going to take apart this so-called trust machine piece by piece. Let's dive in.
Everything we're about to explore really boils down to this one simple question. What if you could send money, or any kind of value, directly to another person, anywhere on the planet, without needing a bank, or PayPal, or any middleman to say okay? That's the core idea we're going to unpack. And this slide really nails the difference. On one side, you have the system we all know. It's built around central gatekeepers, right? The banks, who have to approve and verify pretty much everything. But crypto flips that script. It offers a decentralized, peer-to-peer model where the system itself creates the trust, and anyone can participate.
So if you're going to get rid of the gatekeeper, you've got to replace it with something. You have to build a machine, a system that can create trust completely digitally between total strangers all over the world. So how on earth do you build that?
Well, the whole thing starts with the blockchain. The easiest way to think about it is like a shared digital record book. Everybody on the network has a copy. When a new transaction happens, it gets put into a block, and that block is then changed to the one before it. This creates this long, unbroken history that, once it's there, is basically impossible to alter. But how do you make sure those blocks are secure? That's where something called hashing comes in. It's a clever bit of math that takes any data, literally anything, and turns it into a unique code, like a digital fingerprint. And here's the cool part. If you change just one tiny piece of the original data, just a single comma, the fingerprint changes completely. It's what locks the blocks together and makes the whole chain secure. Okay, but hold on. If you've got thousands of computers all around the globe, how do they all agree on what's true? How do they know which transactions are legit? That's the job of the consensus mechanism. It's basically the rule book for the network that lets everyone vote and agree on a single version of reality without any boss or central server calling the shots. So let's follow a transaction from start to finish. It all begins when you sign it with your private key. Think of it as your secret, unforgeable digital signature. That request then gets broadcast to the whole network. From there, participants, called miners or validators, grab it, check it against the rules, bundle it into a new block, and add that block to the chain. And once it's confirmed, that's it. It's permanent. Now, there are a few different ways for the network to agree on things. The two big ones are proof of work, which is what Bitcoin uses. It relies on raw computing power to solve a puzzle. Then there's proof of stake, which relies on participants locking up their own coins as collateral. The main thing you need to know is the trade-off. Proof of work is like a fortress, but it uses a ton of energy. Proof of stake is way more efficient. We're talking over 99% less energy. Okay, so we've built our digital trust machine. It's secure, it's transparent, it's locked down with some serious cryptography. But what happens if a totally new kind of computer comes along? One that could potentially break the very codes that hold it all together. This isn't science fiction, my friends. This is the quantum threat. Right now, the digital signatures, the hashing, all the stuff we just talked about is basically unbreakable for any computer that exists today. I mean, it would take billions of years to crack. This is the security that underpins not just crypto, but our entire digital world. And this is where the story takes a turn. See, quantum computers don't play by the same rules. They can tackle certain types of problems that are just flat out impossible for the computers we have now. And that poses a direct existential threat to the way we do cryptography today. The attack really comes in two flavors. First, there's Shor's algorithm. This is the big one. It could potentially figure out your secret private key just by looking at your public address. That's like getting your house key just by knowing your street address. The other one, Grover's algorithm, is more about brute force. It could speed up the process of cracking those digital fingerprints, weakening the links in the blockchain itself. Now, before you panic, this isn't some doomsday scenario that nobody saw coming. The smartest people in cryptography have been working on this problem for years. The race is officially on to upgrade our entire digital world to be quantum resistant long before these machines are powerful enough to be a real threat. The answer is a whole new family of math problems called post-quantum cryptography, or PQC. We don't need to get into the weeds on the math, but the strategy is what's really interesting. One of the best ideas is using what's called hybrid signatures. This means a single transaction is secured with both a classic signature and a new quantum-resistant one. It's a belt and suspenders approach that keeps us safe from both today's threats and tomorrow's. So let's assume we've solved the quantum problem. The system is future-proof. What's the end game here? It's not just about creating a new investment asset. The real vision is to build a whole new set of rails for payments. The goal is to make sending digital money as simple and as widespread as something like India's amazing UPI system.
But to get to that point, a few things have to happen. We need simple wallet addresses that people can actually remember, not just long strings of random letters and numbers. Transactions need to be instant and basically free, which is what Layer 2 networks are built for. The value also needs to be stable, which is where stablecoins come in. They're pegged to a real-world currency. And you need it to work everywhere, even with things like offline payments for places without great internet. Let's make this super practical. Picture a street vendor in Gandhinagar. A customer walks up and scans their QR code. They use their fingerprint to approve the payment with a digital rupee. The transaction happens instantly, the fee is practically zero, and the vendor has the money in their account right away. This isn't some far-off sci-fi concept. The tech to do all of this exists right now. And this is why it all matters. Think about something like international remittances, sending money home to your family. The fees can be brutal. With this new kind of infrastructure, we're talking about a potential fee reduction of up to 96%. That's not just a small improvement, that's a game changer that puts more money directly into the pockets of the people who need it most. So if there's one thing to take away from all of this, it's that the technology is growing up. It's slowly shifting from being just a speculative asset to becoming the foundational plumbing for a new, global, open financial system. So the real question isn't just what is crypto anymore. It's becoming what will we build on top of it? And are we ready for what's coming?